So today we start our next unit. So chapter or unit 4 is all about the atom. The atom is, of course, the smallest particle in existence. It is what, if you break every element down to its smallest thing, it will stay its same shape or same substance as long as it stays to the atom. Now you start removing different things and adding different things like protons and neutrons, which we talk about in a second, or adding or subtracting electrons, it becomes something different. It is no longer an atom. It is no longer that specific element. Now, that doesn't mean it doesn't change at all, and it doesn't mean so. The greatest idea, so this idea actually came from our Greek philosophers. So Aristotle and Democritus came up with the idea of the atom, and they said that you could break. Aristotle said that you could break it down infinitely. Democritus or whatever the heck his name is, however you pronounce it, he came up with the idea of the atom. That something can be the smallest it can be without being broken down further. During the Dark Ages, we talk about how the Dark Ages is the study of science is all but lost, but really, this is my little history lesson for the day. During the Dark Ages, which is what Anglo-Saxon calls the Dark Ages because there was less understanding of science, it was when the places like Turkey and the Ottoman Empire were actually thriving when it came to science. We use their contributions as well, but we don't think about it as much, considering chemistry is more we think more about chemistry after the Dark Ages than before. John Dalton comes up with the concept of an atom. It's this sphere. It looks like it's just a small sphere. It has a solid shape. There's no parts of it. It's just the smallest something can be. So he comes up with this idea. Now, Dalton's theory is that atoms are indivisible. He can't divide them any further. They are solid spheres, and it stays the same of the element alike. So as you see this element grow, you have full, unique gold. So let's say you have a piece of gold. It is all gold. It is all those little spheres combined into one. That's what he's saying. And then, of course, they're going to look different. Like if you see gold, it's going to look like that little sphere, and it will look differently than what a sphere of, let's say, francium. Now, J.J. Thomson comes up with this plum pudding because he discovers an electron through his different experiments. So he actually comes up with the idea of He comes up with the idea of the plum pudding model, that there is all these little positive charges. So dough is the positive plum, or is a positive pudding, and the raisins are the plums, or the electrons. All these negative charges. So all these negative charges are just floating in this sea of positive charge. So this explains the electrical charge properties of the atom. The plum pudding model, all your positive area, almost a gas or a solid that has all these plums or the electrons attached to it. Now, Rutherford comes up with a new idea. So Rutherford discovers the proton using the gold foil experiment. So he sees that there's actually a lot of empty space around in an atom. But if you shoot these positive beta particles through, it should come up and they bounce off of this center. Now that shows that the electrons are around there and around this proton. So Rutherford comes up with the relative idea of what we see our model is today. We have the nuclear model now. Now Chadwick discovers the neutrons inside of the nucleus, which creates more space for this nucleus. Now, if you're shooting these beta particles in, it's only going to bounce off positive because beta particles are positive. So it bounces off a proton, so that gives us the charge of a proton. But neutrons have no neutral charge. They're just attached to this proton. Now, when we talk about the model today, we go more off of Bohr's model. So Bohr has this understanding that electrons assume specific orbits around a nucleus. So this means that they will fill in a specific energy level as they go along. So we'll talk about more about this after we do the periodic table. So a couple of units, we're going to talk more about the electron and how they have a specific energy level, and it goes very well with the periodic table. Now, the model is called the planetary model because you think of it, we're heliocentric, so all the planets go around the sun. That's from gravitational pull. This is from your charges of the protons and the electrons. Now, the energy levels are normally found in their ground state. Now, ground state means that this is the normal place that you'll find this electron. That means that if it becomes excited, it changes around. We'll talk more about the spectrum later, but well, as in right now, sorry. But as an electron absorbs energy, it gets excited and moves from one level to another. This can be discovered through seeing it through a spectrum. We see the different light as it jumps. So when we have the excited molecules, we can create a different hue of light depending on what electron is excited and which element it is. This light is emitted once it returns back to its ground state. The amount of energy the electron absorbs or emits to change this energy level is called a quantum of energy. The light emitted is called a photon. So you've heard of photograph. Well, a photon is a particle of light. The quantum of energy is the amount of energy that is absorbed or emitted from this. So our modern model looks more like a blur because we base it off of where the electrons are at any point in time. They are moving constantly. They're moving from one element to the next. They're moving from between energy levels. It predicts about 90% of the time where that electron is going to be. So we look at this cloud model. It represents the history of where the electron has come and where it will probably end up, where it's going. So we can see where a specific one is going. So this modern model shows us within a 90% accuracy where your electron is going to be. All right. And that is all for today. So we will talk about the next unit on another Edpuzzle. All right. Bye.